Hello students, myself Mosam Pandya. Once again we are here with measurement in industries. Our ongoing topic is strain measurement, and under the strain measurement we will be looking into the different types of resistive strain gauge, where we will be looking into types like wire, foil type, semiconductor type strain gauges. So let us go ahead with today's topic. Before that, let us recall or recap very quickly what we did in the previous session, and that was all about resistive strain gauge, where we had bonded strain gauge, we had unbonded strain gauge, and gauge factor. In fact, for bonded and unbonded type of strain gauge, we just saw the simple configuration, and we basically focused on the derivation of gauge factor. You must remember that K is equal to 1 plus 2 mu. So let us go ahead further. So strain gauge arrangement, first of all let us keep in our mind where here you see the strain gauge is connected, two wires or two connections are given to the Western bridge, and as you know, Western bridge is one of the device where you can measure actually resistance, but we here use Western bridge as we will be supplying here, and in balance condition the strain amplifier which is connected across two points diagonally, where it should be zero under balance condition. It means when strain gauge is connected, when it is in balance condition, when there is no stress applied, no strain measurement is there, the reading is zero, and hence it is say preloaded balance condition, and as and when the load is applied, that will unbalance the bridge, and that output will be sensed by the bridge, and then amplification and analog to digital converter and memory. So this is the entire one ideal system where strain gauge is to be used. So let us see what is strain gauge for us. So we have been talking about sensors, so many sensors. So it is one of the sensor which actually measures or sense the strain for you, like say force, pressure, tension, weight, and that will convert into electrical quantity which you can measure. So this is basically a passive type of electrical strain gauge. Passive means it needs a supply, it is not a self-generating type of, and strain varies point to point, and basically they are made as much as possible. Like we will see the comparison and scale with which it is being made, and you here see the length will be approximately 5 mm, and it is used for very small measurement, approximately 1 micrometer. Like say if you are standing on a cement beam, and some more or 2 or 3 more people are walking through a cement beam, so probably we are not able to understand is there any bending is there or not, because it is actually beyond our sensation. So if a 1 micrometer, like 10 raised to minus 6 meter variation is there, it will be sensed by the strain gauge, and very sensitive material we are using within the elastic limit of the material, and the unit is microstrain, where change in length micrometer per unit meter of the length. This is a very standard terms in case of strain gauge when we talk about, and the microstrain will be the unit. So basically what are the types? Let us see. That is mechanical type of strain gauge. Basically levers and gears will be utilized to reflect the change in the length or displacement due to application of the stress and strain. Another is optical, where magnification from the mirror or prism you can use, and the third is electrical, where we will be sensing the change in resistance or inductance or capacitance, and ultimately we will calibrate our meters in terms of microstrain So our focus will be basically on electrical type of strain gauge, where we will go for some resistive kind of strain gauge. So how does it look? First of all, you see, this is all theory, and here I am teaching you online, so you should know how does it look like. We must see that. So see here I'm showing you one diagram, and probably if you remember in our offline classes in semester 4, I had shown one small arrangement on paper where we established one thread in grid-like condition, and we got two ends. So here you see the picture, and I'm showing you another. Actually, the scale you can imagine, like you see the scale of the actual strain gauge. Basically, this is one of the foil type of strain gauge that we'll see ahead. So this picture is larger picture, and this is the very small one. This is actual. So this is quite magnifying. And one more thing is, this was actually established, or this was actually first time fabricated during some 1938, 1943. Probably in India, we were struggling for our independence, and the scientists in Europe, they were doing this kind of innovations. And now the second picture you see here, that is actually we are utilizing the strain gauge. So the quantum, the scale of the strain gauge is very small. So please keep in mind, this is a very meticulous, small kind of sensor, and can be adjusted anywhere within a very small space. So let us see some material which we know, we should know. So basically nichrome and copper, chromium, these are the very popular material which are having quite good elasticity, very good sensation, very good response to the resistivity, linear resistance. So these are some material and combinations, and nichrome, constant and nickel platinum combinations, and isoelastic combination where nickel, chromium and molybdenum we are using here. So our study will be focused today on bonded type and unbonded type of strain gauge, which are actually subtypes of wire wound type strain gauge. Basically, there are three types of electrical, means resistive strain gauge. That one is bonded strain gauge that we had already started. Another will be unbonded, and then after wire wound type, there will be metal foil type of strain gauge, and third one will be the semiconductor type of strain gauge, where we will be using the concept of piezoelectricity. Now let us look at the word bonded. Bonded means something is fixed on some platform. So here you see two diagrams which you displayed on the screen, where force is applied and structure under, it can be a beam, it can be the platform for a swimming pool, or the platform of a very high altitude, high rise story building, where we have to measure what are the impact of the high pressure wind and how much it can withstand against the such kind of pressures. And as I have shown you, they are very small in structure. So basically, this is what we have. A very small grid of wire is formatted, and two ends are taken out. But here the grid is fixed with the adhesive on some platform, and then that felt, means material from textile fiber made is overlapped, and entire strain gauge is made. So let us see how actually layer by layer the strain gauge is formatted. We are talking about wire wound bonded type of strain gauge. Wire wound bonded type of strain gauge. So once again, our that popular and resistance to be measured across the two outcoming ends. So this is the platform or surface on which we will be putting our strain gauge. Then this is the another layer, or you can cement adhesive, then another platform, and this is the grid, wire grid. So let us see what are these locations. So here you see specimen surface, or it's like a beam under observation. That substrate you can see here, then adhesive cement that in pink color I have shown, and the felt means it's a textile material that is produced by the condensing or pressing the fibers together, and wire grid, which is shown with the red color here. Let us go a little bit ahead. The bonded strain gauge, there are certain facts that you should remember, or it will be required actually when you actually write down the theory, or you go for some MCQ kind of question. So it's a grid of fine resistance wire. The diameter is very small, like diameter of the wire 25 micrometer or less. The size 3 mm by 3 mm. Now you can imagine what should be the size of the actual sensor, which can be actually fixed on the on your nail also. The resistance value will be varying from 120 to 1000 ohms for the calibration, and excitation voltage it is a usual range of 5 to 10 volt DC that we are using with the Western bridge. Now next is unbounded strain gauge. So now you understand what is unbounded strain gauge, where something is not fixed, not bonded, that is unbounded. So here on the screen you see, once again let us go step by step. It's actually set of preloaded resistance wire, and all are equally taut. Taut means they are equally stretched already and connected as 4 arms of Western bridge. We see we know Western bridge has R1, R2, R3, R4, 4 arms we are making. They all should be balanced in the null position or when no load is applied. So here the wires are stretched in such a way that they are say preloaded, and in such condition it will give you 0 reading. Now force when applied, say right now force is applied from your right to left. Okay, so there will be 2 wires, the wire number 1 and wire number 4. Here I say the wire number, let me give wire number for you. I say this is wire number 1, wire number 2, wire number 3, and the 4th grid wire. So I am talking about this first and 4th will be stretched with the application of force in the shown direction, and here number 2 and number 3 will be compressed, or the tension will decrease in this number 2 and 3. Now what will happen? As usual, our Western bridge will be unbalanced, and that output voltage, the unbalanced voltage, will be calibrated in terms of the displacement actually, which is actually due to the strain. So let us go ahead. Now let's have some conceptualize actually how does it work, that we can see here. You just observe the animation that I'm showing you here. These are the R1, R2, R3, R4, 4 wires are there, and simultaneously you see here according to the arrangement you observe the red colored and blue colored strain gauge arms. Basically they are the 4 resistances of the strain gauge. It can be combination of 4 resistance, it can be combination of 4 different strain gauge, or it can be part of one strain gauge. And here you see the balance condition comes at the 0 voltage when V becomes 0, or else in the any of the direction the varying load, supply voltage is 10 volt, and this is actually Western bridge, this is actually galvanometer, it should be 0 under the no load condition. Okay, and the voltage division rule we apply, and we get the final voltage, and that will be actually characterized, or you can say calibrated in terms of micro strain. Now the second type, wire wound, we had seen the bonded and unbonded. Now the second type is foil type. It is actually extension of the wire wound, where the wire had to be fixed with the adhesive. Here little bit different technology is utilized, and you see the diagram, and you will be able to see that it's a foil. Foil means a layer. So metal foil of a very small thickness, say around 5 micrometer, and it is actually produced like a printed circuit technique. Like it is as good as like you print circuit on PCB. Similarly, we have to print the grid on a plastic backing by using, say, photo etching or vacuum deposition process. Basically, see, we will not go in the depth of how photo etching or vacuum deposition process is done. You can find out somewhere on the internet, and it is actually done on the one side of plastic. It is as good as like you are generating a printed PCB, and leads are soldered. These are the leads. These are soldered with the ends of the metal foil, which are actually made little bit fat. So this is actually how original or one actual strain gauge, foil type strain gauge is looking like. And you see these are the small, very small thin line grids are shown here. And these are the fat lines which are created purposefully to avoid the spurious effect of the transverse strain. Transverse strain means we are talking about right now, say left to right, right to left, and if you go on the cross, so those effects should be removed, and it can be prepared in any form, like, and it can be combination of 2, it can be combination of 4, and even 4 different strain gauges are connected in the 4 arms of the bridge to measure the multi-axial forces also. See, here I am showing you the combination. See, the 1, 2, 3, 4 and 5. So these are multiple measurement. It can be the arms of the 4 arms of the Western bridge, and another for the calibration you can use. So any combination you can find out, and you see the actual foil type of strain gauge is looking like this in this picture, where the actual leads are soldered with the fat end of the metal foil. So this is all foil type strain gauge. And please recall the scale of actual formation. So again, I request you to remember the small size of the strain gauge, which can be actually fixed on your nail also, and we are trying to see a bigger picture on this. So I hope you understand the wire wound and foil type of strain gauge, and we will be closing here our session for today. And what will be the upcoming topics? That will be third type that we are going to see, that is semiconductor type strain gauge, and some static and dynamic measurement with help of Western bridge, and one more important question which will be asked in the examination, voltage sensitive bridge. See, soon we will be releasing the question bank, and in question bank you will find this question is asked repeatedly, voltage sensitive bridge. And further in the more upcoming session, we will be looking at the fiber optic type of strain gauge and some minor calculation, and your chapter will be over here. Thank you so much. Please subscribe the channel if you haven't subscribed. If you have any doubt, you can write down on the email ID given here. and please keep watching the video, revising video. This is going to be an online teaching for further more days. Even after we expect that till 15th August we will be doing this, and online exam is going to be conducted. So you must keep revising, and we are not deleting videos from our channel, so you can watch it your comfortable time, and you can revise it. Thank you very much. Thank you so much. We will be meeting in the next upcoming session. Thank you.